G'day all, and welcome back to our trigonometry series for 5.3 mathematics. In this video, we are going to explore the unit circle in terms of all four of its quadrants. Previously, in a different video, we saw the first two quadrants, the one where everything is positive and the quadrant where only sign is positive. We're going to now explore the other two quadrants and do some problems involving all four of them. Okay? So it's the entire unit circle now. Okay. So just remember that for the different quadrants, cosine theta and sine theta can be positive or negative. Okay? And please just remember that tan theta is sine theta over cosine theta. So let's write a few of these little notes down. Alright, so for different quadrants, sine theta and cos theta can be positive or negative, depending on where it sits. Okay, and then just remember that tan theta is sine theta over cos theta. Okay. Probably not the most help at the moment, but let's start seeing a few little things in action, and we'll give you a bit of a hint to know how to recognize whether it's going to be positive or negative depending on its quadrant. And we use a little bit of a mnemonic, and that is the saying all stations to Central, or it could be all stations to Canberra, whichever one you want to do. So let's draw up a quick little unit circle here, or a quick little quadrants / coordinate plane, and let's label our quadrants. So our quadrants are 1, 2, 3, 4, and I am just going to use A, S, T, and C. A, S, T, and C. So what that actually means, in quadrant 1, all ratios are positive, or all of our sine, cosine, tan are all positive. So all ratios are positive. In quadrant 2, only sine ratios are positive. Should say is positive, shouldn't I? And only sine is positive, so cosine and tangent will both be negative. In quadrant 3, tan theta is positive. And remembering that tan theta is just cos theta over sine theta, which means that if they're both negative, tan theta has to be positive. Okay? And then over here in quadrant 4, cos theta is positive, because the other two will be negative. So that's our four quadrants. That is the little saying, all stations to Canberra. So all stations to Central or Canberra, whichever one you want to use, fine by me. Just know that A is for all ratios, S for sine ratios, T for tangent ratios, C for cosine ratios. In terms of that, we also have what we can call a reference angle or a related angle. It is an acute angle that helps relate to cosine theta or sine theta depending on what we need. So let's have a quick look at some of those. So reference angles are acute angles, okay, and they help relate cosine theta and sine theta to the first quadrant, because that's going to make life a little bit easier. Okay, and here's what we can see. So if we have the angles from 90 to 180 degrees, okay, that's 180 degrees minus theta. From 180 to 270, well, theta minus 180. And then from 270 to 360, 360 minus theta. So we're looking at this section here. All right, we do this. So for all those angles, always coming from that horizontal, as you can see in that diagram. And you can see it's matched on the other side. We can also see for this section, it's doing the same thing in that first quadrant, but now we're going theta minus 180. And then for our final quadrant, it's doing almost exactly the same thing as well. So that's for this one. Okay, hopefully when we start looking at some examples, this will make a little bit more sense for you. Just remember as well, exact values can be used in this case. And that can be used for the angles of 30 degrees, 45 degrees, and 60 degrees. So use those exact values as you need to. Okay, if it is multiples of 90 degrees, here's a little table that is going to help you out when there is multiples of 90. You can see their sine theta is either 0, 1, 0, minus 1, or 0 again. That's going to help us out in the next video actually, as is the cosine one. Not so much the tan one there. It is going to help you out a little bit though. Now that we've gone through a little bit of that, let's have a go at some examples just to see what's happening. Alright, our first example there. Decide in which quadrant theta lies and state whether sine theta, cos theta, and tan theta are positive or negative. Our first one there is theta equals 300 degrees. So, quick little quadrants. Alright, theta is going to come all the way around here. Alright, and that's going to be 300. So we actually want the inside angle here. That's the angle we want. So that's what we want as our reference angle. And that's going to be in quadrant 4. Alright, but that's our little reference angle in here when we're talking about those. Quadrant 4, so if we remember quadrant 4, it was C, so cosine or cos theta, let's do it as cos theta. Cos theta is positive, and then the other two, sine theta and tan theta, are negative. Always helps to draw yourself a little diagram. Alright, again, let's whack out a little diagram of our coordinate plane. And let's look at 230 237 is going to come all the way around here, thereabouts-ish, which means it's going to be in quadrant 3. Quadrant 3 means that tan theta will be positive because that is the T quadrant for numbers being positive. Sine theta and cos theta will be negatory or negative. Okay, now we were talking about reference angles earlier. Let's have a look at some reference angles. Here is sine 330 degrees. So let's pop a diagram. Let's pop a diagram on. Let's do a better one. Okay, 330 degrees is going to go a fair way around. So we're going to be around here somewhere. And it's the reference angle in here. So we want to come off that x-axis. Okay, we want to make sure we're coming off the x-axis. So it's going to be theta. So we're going to go 360 minus 330. So theta equals 30 degrees. But it is going to be sine 30. So we want minus sine because we're in the fourth quadrant. So it's going to be minus sine 30. Okay, minus sine 30. Not sure whether this is working out the way I want it to come across, but hopefully it will look a little bit better in this next one. Let's look at cosine of 162, cos of 162. Another little coordinate plane here. 162 isn't going to go all the way around, it's only going to come to about there. And we want the reference angle, which is in here, which is going to be theta. Alright, this time though we're going to have 180 minus 162 to get to our reference angle, and that is going to give us 18. It is cos theta, so cos theta in quadrant 2 is going to be the negative, so it's actually going to be minus cos 18 degrees. Alright, so remembering our all stations little rhyme, so A, S, T, C. So if it is a sine ratio that we had just done there, it would have been positive, but it's cosine, so it has to be negative. Last one there, let's have a look at this one. Another little diagram. This time it is tan of 230. So tan comes around here. This will be 230. And we want to go the other way a little bit. We actually want to go 230 minus 180 this time. If you looked up here, that's where we're at for this one. So we want 230 minus 180. That is going to give us 50. So our little reference angle in here is going to be 50. And because it is in the T section of our quadrant where tan is positive, we're actually going to have tan of 50. It's going to be a positive ratio. Have a go at these questions, guys. Good luck with them. Remember our 4 quadrants, where we have quadrant 1 is all of our values are positive. Quadrant 2, all the sine ones are positive. Quadrant 3, it's all the tans that are positive. And quadrant 4, all the cosines that are positive. Good luck with those questions, and I'll see you in the next video.